Today we're looking at regular polygons and how to find the area for them. So just a reminder, a regular polygon is a polygon where all the sides are the same and all the angles are the same. So we're going to define terms that have to do with regular polygons, and then we're going to look at the formulas for the area of regular polygons, and then we're going to look at the relationships between apothem, altitude, and then the side of an equilateral triangle. So the first definition we want to look at is the center of a regular polygon. So you've heard of a center of a circle, and that's something that you're familiar with, but regular polygons also have centers. It's the common center of the inscribed and circumscribed circles of the regular polygon. So here is a polygon, and so if we wanted to find the center of this polygon, we would look at the inscribed circle and then the circumscribed circle, and then the center that those both share, that is the center of our polygon. So there you go. All right, next definition, a radius of a regular polygon. So just like a circle, polygons can have a radius as well. A radius connects, it's a segment, and it connects the center with one of the vertices. So vertices. So remember, the vertices is kind of like where the segments join together. So it's kind of where like the angles are. So the radius connects the center to an angle. All right. So or a vertex. And then we have a radius, and then we have another line that comes out from the center, and that's called the apothem. So the apothem is different from the radius because the radius goes to the vertex, whereas the apothem is a perpendicular segment with the side of a polygon. So it's a perpendicular segment from the center to a side. So it's going to the side and not going to the angle or the vertex. So here is a polygon, it's a pentagon. So here's the special parts of a regular polygon. First we have the center. Then we have a radius, which connects the center to a vertex. And then we have what's called the apothem, which is the perpendicular segment that connects the center to a side. So remember, a perpendicular segment means it's going to hit that side at a 90-degree angle. All right, another definition is called the central angle of a regular polygon. So the central angle is the angle formed at the center of the polygon by two radii drawn to consecutive vertices. So if you can draw two radii, one to one vertex and the one to the vertex right next to it, that angle that you create at the center, that's the central angle. So here is an example of a central angle. So you start at the center and you draw a radius, and then you go to the center and you draw a radius to an angle that's next to it, consecutive, right? Consecutive, they share the segment in between them. So once you've drawn those two radii, the angle formed at the center, this angle right here, we call this the central angle. So angle RPQ is our central angle for this polygon. There is a formula to calculate the degrees of a central angle. So whatever sided polygon you have, so whatever n-gon you have, so whatever sides, this is how you get the central angles. So first of all central angles are congruent, and to get the measure of them, you take 360 degrees and you divide it by n, where n is the sides of the polygon, or how many sides of the polygon has. So let's say we wanted to measure, if we're looking at this polygon, and we wanted the central angles. So the central angle is 360 divided by the number of sides. Well, since this is an octagon, we divide it by 8. So that means it's 45 degrees. So the central angle RPQ is 45 degrees. And then to figure out the base angles, so base angles would be these angles here, right? angle R right here, and angle Q right here. So to figure out those base angles, well, you know this is a triangle that adds up to 180. So if this is 45, then these two angles have to be 180 minus 45, which is 135. Well, we know that these two sides are congruent because they're radii, which means this is an isosceles triangle, which means our base angles are also the same. Angle R and angle Q are congruent. So if we know they add up to 135, because 180 minus 45, which is what our central angle is 135, then if we want to figure out what each of these are, we can just take 135 and divide it by 2, and we get 67.5 for our base angles here. All right, there's a formula of for the area of a regular polygon. It's 1/2 the product of the apothem and its perimeter. So 1/2 A times P, where A is the apothem, so the apothem goes from the center to a side, and the perimeter. And so the perimeter is where you add up all the sides. It's the length of the outside altogether. So there's another formula for the apothem of an equilateral triangle. So the apothem is going to be 1/3 the height of the, it's going to be 1/3. So, and here's another formula. So the apothem of an equilateral triangle is the square root of 3 times 1/6 the length of a side. So here's a formula for the apothem of an equilateral triangle. So A is equal to the square root of 3 over 6 times S, where S is one of the sides of that equilateral triangle. So that's how you can figure out the apothem. Okay, so let's say we want to find the area of this octagon, okay? So we have an apothem and we have a side. So the formula for the perimeter is the number of sides times the length of one of the sides. So since this is the octagon, we have 8. And so each side is 10, so we have 8 times 10 is 80. So that's the perimeter of this octagon. So now that we know the perimeter and we also know the apothem, we can use our formula for the regular polygon, which is A is equal to 1/2 apothem times perimeter. So our apothem is 12 and our perimeter is 80. So 1/2 of 12 is 6, and then 6 times 80 is 480. Let's say we wanted to find the area of this regular hexagon, okay? So we know that our central angle, so this angle right here, this central angle is equal to 360 divided by the number of sides, which is 6. So 360 divided by 6 is 60 degrees. And if this is 60 degrees, then that means that, and these angles have to be congruent because they're base angles, that means that all of our angles are the same. This is 60, 60, and 60. And if all of our angles are the same, that means that we have an equiangular triangle in the middle of our hexagon, which means we also have an equilateral triangle, which means all sides are the same. So if this is D, then this is also D, and this is also D. All the sides are the same. Okay, so using that information, let's say that we know that this side is equal to 4, okay? And that means that side's equal to 4, okay? And if that side's equal to 4, and this is a perpendicular, that means it split this 4 into half, so this is 2. So now this is 2, and this is 4, and we can figure out A using the Pythagorean theorem. 2 squared plus A squared has to be equal to 4 squared. Which means that A is equal to the square root of 12, which can be simplified to 2 square roots of 3, because the square root of 12 is the same as saying the square root of 4 times the square root of 3, and the square root of 4 is 2. So that's how we get that our A is equal to 2 square roots of 3. All right, so in going back to finding the area of this regular hexagon, well, so now we know that one of our sides is 4. We also know that our apothem is 2 square roots of 3, which means now we can use our formula. A is equal to 1/2 A times P. Our A is 2 square roots of 3, and our P is 4 times 6, since we have a hexagon, which is 24. So now we can simplify. 1/2 of 2 is just 1, so now we've got the square root of 3 times 24, which is 24 square roots of 3. All right, go ahead and try some problems on your own.